Friends, in this video we are going to see how to convert a regular expression to DFA. So to convert a regular expression to DFA, we have certain steps. The first step we have to do is we have a regular expression. So here if you see, this is the regular expression we have considered. To this regular expression, we have to append or we have to augment this regular expression with the unique end marker hash. So you can see this is a regular expression. To this regular expression, we have added an end mark hash. So this is the first step. So after adding this end marker, the next step is we have to construct the syntax tree for this regular expression augmented with the hash. So when we construct a syntax tree, we have certain nodes for the syntax tree, that is star node, which have only one child, concatenation node, which have two childs, and OR node that also have two childs. So this is the second step. So here you can see for this regular expression, there is a syntax tree constructed. And the next step is for all the leaf node in the syntax tree, we have to assign a unique integer value. So you can start the integer value from 1, 2. So for all the leaf node, we have to assign a unique integer value. And then after assigning this integer value, we have to compute certain functions. So there are 4 functions we have to compute, that is nullable, first position, last position, and follow position. After finding all these values, then we have to construct the DFA. So we are going to see this with an example so that you will understand it properly. So let's take an example. Here I am going to take a regular expression. I'm going to take a simple regular expression. Say for example A concatenated with A or B whole star, and that is concatenated with B. So this is what the regular expression we have considered. So what is the first step? To this regular expression, we have to augment a special unique symbol, that is hash. So we have augmented it with hash. So that is the first step. Then what is the second step? We have to construct a syntax tree for this regular expression. So we are going to make a syntax tree for this. So first what I am going to do is I am going to make a syntax tree for this part. So I am going to say A and or B, right? So A or B, so that part is over. And we know here you can see the whole star. For A or B, we have to find a star, okay, the clean closure. Then we can see this part A or B, the whole star, is concatenated with a symbol A. So this part is concatenated with a symbol A. And then along with this full A concatenated with A or B, the whole star, that is concatenated with B. So this part is concatenated with B. And then you can see that is again concatenated with hash, the augmented end marker. So the syntax tree is over. So we have done with the syntax tree. So what is the next step? For each and every leaf node, we have to assign a unique integer value. So let us assign some integer value for it. So let me give some number for the leaf node. Let me say the number is, for A I am going to give 1, 2, 3, 4 and 5. So this is how I have assigned some integer value for all the leaf node. So the next step is, now we have to find the sum, we have to compute some of the functions like nullable, first position and last position. So if you see here, the rule to find this is, for a leaf node with the position I, if it has some position, the nullable value is false. And what is the first position for the leaf node? The I value itself. What is the last position? The I value itself. If it is an OR node, then the nullable value is nullable value of child 1 or nullable value of child 2. If how to find the first position? First position of child 1 union first position of child 2. And the last position is last position of child 1 union last position of C2. So here there is a rule to do how to find nullable first position and last position. Let's see with an example so that you will clearly understand. So we have to find first position, last position and nullable. So already we saw here, if we have some value, we have a leaf node with some position, then the nullable value of this node is false. Okay, and what is the first position? The I value itself. So for A, the first position is 1. What is the last position? The last position is also 1. So that's what we can see here. For a leaf node with the position I, nullable is false. First position is the I value itself. The last position is I value itself. Right? So that's what we have did it here. So similarly for this node also, since it has some position value, the nullable is false. And the first position is the position value itself. And the last position is also the position value, the 2 itself. For this again, the nullable is false since it is a leaf node with the position and the first position is 3, the last position is also 3. And then again we will find for all the leaf nodes, for this leaf node, again since it is have some position, the nullable value is false and the first position is 4, the last position is 4. And for this node, again it has some position value, so the nullable value is false. The first position of this is 5 and the last position of this is again 5. So for all the leaf node, we done with nullable first position and last position. So now we are going to move one by one upward. So here, if I start with this, I know the first position, last position and nullable for this child C1 for this concatenation node, but we don't know the value of this, right? So we'll start from here. So here we have a R node. So for this R node, again we have to find what is nullable first position and last position. So R node, what is the rule to find the nullable? For a R node, the nullable value is like nullable value of C1 or nullable value of C2. So here the child is this and this. So the nullable value of both of them is false. So false or false is the nullable value is here again false. Then how to find the first position and last position for the R node? So to find R node here, the first position is first position of C1 union first position of C2. So here to find this, so what is the first position of C1? This is the first position of C1. This is the first position of C2. So here the first position of this R node is 2, 3. And what is the last position of this R node? Here again you can see the rule for the last position is last position of C1 union last position of C2. So here we have the last position of this is 2, the last position of second child is 3. So here again we have 2, 3. So this is the first position and last position for this R node. The next one is star node. So how to find the nullable for star node? If you see here in this formula, for a star node, okay, the nullable value is true. So here you can see for a star node. So here this is a star node, right? So this is a star node. For the star node, the nullable value is true. So here automatically we can write the nullable value for this is true. And what is the first position and last position for the star node? It is first position of the child C1 and the last position is last position of the child C1. So here for the star node, who is the child? This is the child, this R node. So same thing will be coming here. For the first position of the child C1. So here again you will get 2, 3. And the last position is same thing here also, 2, 3. So we did with this, right? So the next thing is we have another concatenation. Next one is the concatenation node. So how to find the nullable value of a concatenation is, you can see here the rule is nullable value is nullable value of C1 and nullable value of C2. So here this child is false and this child's nullable value is true. So false and true is, we know false and true is false itself. So here the nullable value is false. Then how to find the first position of this concatenation node? If the nullable of child C1 is true, then we have to find first position of C1 union first position of C2. Else we have to find the first position of C1 itself. So if you see here, for this concatenation node, for the C1, the nullable value is false. So we have to go to the else part. What is the else part? If the nullable value is false, we have to take the first position of C1 alone. So here the first position is 1 itself. Now come to this side. So side C2, for the child C2, here again to find the last position. So what is the formula is, if the nullable value of C2 is true, then we have to take last position of C1 union last position of C2. Otherwise, we have to take the last position of C2 alone. So if you see in this example, for the child C2, the nullable value is true. So if the nullable value is true, then we have to take the last position of C1 union last position of C2. So this is C1 for this concatenation node. This is C2 for this concatenation node. So we have to take the union of this last position and this last position. So here you will be getting 1, 2, 3. So this is the last position of this concatenation node. So let's move on to the next one. For this concatenation node, so we know already we saw. So how to find the nullable of this concatenation node? We have to see the two childs. So here the nullable is false and here is also nullable is false. So false and false is, it is false. Now we have to find the first position and last position of this concatenation node. So here we know if the C1's nullable is false, then we have to take the first position of C1. So the first position of C1 is 1. And come to the second child. So here if you want to find the last position of this concatenation node, we have to check the child 2. Here again the nullable value of C2 is false. So if it is false, so you can remember this one. If this is false, then we have to take the else part, that is last position of C2. So what is the last position of C2 here? That is 4. So here it will be like 4. So this is the first position and this is the last position. So finally we came to the last concatenation node. Again we know how to find the nullable. So this is the child C1 and this is the child C2. So here is also nullable is false. Here is also nullable is false. So false and false is again it is false. Then we have to find the first position and the last position for this. So we have to, for the first position, check the child 1. Here the nullable value is false. So if the nullable value false, we have to take the first position of C1. So that is first position of C1 is 1. And how to find the last position? To find the last position of a concatenation node, we have to check the child 2. Here for the child 2, the nullable value is false. So if the nullable value is false, then we have to take the last position of the child C2. So here the last position is 5. Right? So we are done with how to find. So here if you see in this step, we have to find nullable. So we did it. We have to find first position, last position. We did all this thing, 3 things, right? The next thing is we have to find the follow position. So let's discuss how to find the follow position. So we can find follow position for only 2 nodes, 2 kind of nodes. Okay, so already we saw there are some 3 types of node: star node, concatenation node, or node. But if you see here, for follow position, we can do follow position only for 2 nodes. Which are they? Star node and node. Only for this 2 we can able to do the follow position. So first we will be discussing about the star node. Say for example, if you have a star node like this, then how will you find the follow position? I am going to teach you with a small example so that you will understand. So we know here for a star node, it has only one child. It has some first position and last position. Let's consider the first position. We are going to consider the first position of star node is A, B, and the last position of star node is C, D. Okay, so we have considered like this. So if this is the case, then how will we find the follow position for star node? So for the star node, you have to do it in anti-clock, like clockwise direction. It will be going like this. Okay, it will be going like, which means for every position of last position of star node have all the position in first position of star, which means what? C, every position in last position of star node is what? C and D. So the C and D will have all position in first position of star node. So all means what? It has A comma B. And for D also it has A comma B. So this is what the follow position. So in the star node we have to move like this. So for every position in last position of star node have all position in first position of star node. So this is how we have to do for the star node. Then how will we do for a concatenation node? So we know that if it is a concatenation node, definitely it will be having the two childs. So let's consider like this. This is child C1 and this is the child C2. If this is the case, let's consider the first position of this is E comma F. Similarly, the last position of C2 we are going to consider as G comma H. And the first position of this is I comma J. And the last position of C2 we are going to consider as K comma L. Okay, so we have just considered. Okay, so in this case, how we have to do the follow position is we have to go in anti-clockwise direction. Same thing only, but we have to move like this. So how will we say? Earlier we said like this. Now we have to say every position in last position of C1 have all position in first position of C2, which means for every position in last position of C2, what are they? G and H. So for every position have all position in first position of C2. So what is there in C2's first position? So G have I comma J, and similarly H also have all position in first position of C2. So it also have I comma J. So this is how we will be finding the follow position. This is the rule to find the follow position. So we will be finding the follow position only for star node and for the concatenation node. So for our example, we are going to find the follow position. Okay, for this example, we are going to do this. So what I am going to do here, I am going to draw to compute this follow position. Let's draw a table. So here I am going to take the first value is position. Okay, position. And the next one is the follow position. Follow position. So let's draw this table. What are the positions we have? 1, 2, 3, 4 and 5. We have totally 5 positions. So 1, 2, 3, 4 and 5. So 5 positions we have. Right. Now we are going to find the follow position for the star node and for the concatenation node, and we are going to fill this follow position. Okay, let's discuss that. Okay, now if you see in our example, where are the star node and concatenation node? So if you see here, for our node, we won't do the follow position. So let's come to the star node. We know star node means we'll do in the clockwise direction. So we know every position in last position of star node have all the position in first position of star node. So what is the meaning? So 2 will be having 2 comma 3. So 2, this 2 will be having this 2. So 2 comma 3. Again 3 will also have all position in this. So 3 will also have 2 comma 3. So we did with this star node. The next thing is concatenation node. For the concatenation node, we will go to with the anti-clockwise direction, right? So here we saw for every position in last position of C1 have all position in first position of C2. So here for 1 we have 2 comma 3. So for 1 we have 2 comma 3. So that's all. Here we have only one position. So that's also done. We go to the next concatenation node. This is the next concatenation node. Again we'll be doing this way. This is the C1 and this is the C2. So for every position in last position of C1 will be having all the position in first position of C2. So here 1 also have 4, 2 also have 4, 3 also have 4. So 1 also have 4 and then 2 also have 4, then 3 will also have 4. Right? So okay, we done with that. We'll go to the last concatenation node. Here again we have to consider this too. So for all every position in last position of C1 have all position in first position of C2. So 4 will be having 5. So 4 will be having 5. So that's all right. So we finished with all the concatenation and star node. So let's close this curly brace. So we are going to close it. So here if you see for the fifth position we don't have any follow position. So we are going to fill it with null. Okay. So this is how we have to find the follow position. So now we have done with the follow position. So now finally we want to find the DFA, right? So if you want to find the DFA, we are going to do one more step. Okay, I'll tell you one more thing. So here we followed some steps to find the follow position, right? By directly seeing the regular expression, this is a shortcut way. You can verify that you have did it properly or not. Directly also from the regular expression, you can find the follow position. So how to do it, I'll teach you. So here, as we have given some number for all the leaf node, same thing you have to give some numbers. Say for example, I'm going to give some number here. Let's say 1, 2, 3, 4, 5. So for all the symbols we have given number. Now if you see here for A, okay, for the position 1 means who is in the position 1? A. Who are all following this regular this symbol A? So this A can be followed by this A or this one, okay, because or B, because A or B, either A will be coming or B will be coming. So 2 will also come, 3 will also come. Since it is 0 or more number of time, sometimes this may not come. So in that case, who will be following A? This B. So who are all the followers of A? The first position 2, 3, 4. So that's why we wrote here as 2, 3, 4. Then go to the second position. If this for this A, who will all the followers of this A? So for this A can be followed by itself because it is A or B. So this can move and it is 0 or more number of time. So in the next turn for the second A, you may get the same A near to it. Okay, so 2 will also come. Or if the B is taken, then B will also come. So 2, 3. And if since it is 0 or more number of time, so if you consider for only one time this, so A will be followed by this B. In that case, you will also have 4. So followers of A is 2, 3, 4. Right? Similarly for the node 3. 3 also will be in the same thing. Because it is inside the 0 or more number of time and inside we have R. So B can be followed by this A. Because for the next time, since it is 0 or more number of time, the next possible near symbol can be this A. So we have 2. Sometimes this B also can come. So 2, 3. If since it is 0 or more number of time, the B can be followed by this B also. So 2, 3, 4. So here you can see we got 2, 3, 4 again. And then now you see this one. 4. Who are the followers 4? 4 have only followed by 5. No other options for this B. So B is followed by only 5. So B means 4. 4 is followed by only 5. So that's why we can see 4 is followed by 5. And then this 5 is followed by nothing, right? So that's why we put here as epsilon. So you can do it in a shortcut way if you are very clear about it. Or you can just use this follow position rule and you can construct this table. Okay. So let's move on to the next step. So now after finding this follow position, we have to find the next thing that will make us to construct the DFA in an easier manner. That is finding the D transition. Okay, we have to find the D transition. So to start with the D transition, how you have to start is you have to start from the root node. Okay, so the start state is, who is the start state? The start state is the root node. The root node's first position. So we have to say first position of root node is considered as the starting state. So here if you see in this index tree, who is the root node? This is the root node. And what is the first position? First position is 1. So here the first position of the root node is 1. Okay. So here if you see in this syntax tree, this is the root node. For this root node, the first position is this. So that is considered initially as the starting node. And instead of representing this as 1, we can give some name to the state. Let's say as capital A. Okay, you can give any name. I have just taken it as A, right? So we have a starting state A which is representing 1. Both are same only, okay? So now we are going to find the D transition of A, the state A on given input symbol A. So we have, if you see in the regular expression, we have some input symbols A, B. These are the two input symbol for this regular expression. So we are going to, DFA means for every state it has to move for all the symbols in the regular expression. So first we have taken A as symbol. So this A represents what? 1. So A represents this 1. So we have to go to the position 1 and you have to say whether A is there. Okay, A symbol is there. Now you can see 1 has A symbol. So if it is having A symbol, then we have to say follow position of 1. Okay, so we have to say the follow position of 1. Because this 1, A represents 1. What is inside 1? 1 have the symbol A. So we have to find the follow position of 1. What is the follow position of 1? It is 2, 3, 4. It is 2, 3, 4. So this will become the next state. So we are going to name it as B. Because why we are giving some name? It will be easy for us. Because instead of every time saying 2, 3, 4, we'll just name it as B. That's just a name. Okay. So we have done with the state A with the input symbol A. Next we have to do for the next symbol. D transition of A state with the input symbol as B. Okay. So here if you say A means 1. In 1, if you see in 1, there is no input symbol B, right? For 1 there is no input symbol B. So here it is null. So we have to take it as null. Okay. So A state is done with symbol A as well as the B. So we'll move to the next thing. D transition of the next state we have found is B, right? So we have to say B on input symbol A. So B means we know this B represents, what are the things B is representing? It represents 2, 3, 4, right? Okay. So now we have to do this again. So it's equal to, so we have to go and see this position 2, 3, 4 and you have to say whether A is there. So if you see here, 2 have A, right? 2 is having A, that's fine. Then 3 is don't having A. So 3 have only B. Position 3 have B. And 4 is also having only B. So in 2, 3, 4 position, position 2 alone have A. So we have to find the follow position of 2 alone. So what is the follow position of 2? Follow position of 2 is 2, 3, 4. So the follow position of 2 is 2, 3, 4. So for this 2, 3, 4 already we have given the name as B. So same thing we have to give. So again we are going to use the same formula as B. Okay. So again we have to find D transition for state B for the input symbol B. Right. Already we know in 2, B means it's represent 2, 3, 4. In 2, 3, 4, we already know 2 is having A and 3 and 4 is having B. Already we saw here 3 and the 4 is having the symbol B. So how will you do? So here we have to say, we'll shortly write follow position as FP. Follow position of 3 union follow position of 4. Right? Because this means it is 2, 3, 4. 2 is having only A. 3 and 4 is having B. So we have take the union of this two. So follow position of 3. What is follow position of 3? It is 2, 3, 4. So it is 2, 3, 4. Then union follow position of 4. What is follow position of 4? It is 5. So we are going to, since it is union, we are going to join it here. And this is a new state. Already we have 2, 3, 4 as one state and 1 as another state. So this is a new one, right? So for this new one, we are going to give the state name as, already we have the name till B. So we are going to name it as C. So we have done with A state, B state. Then we will go to the next new state we got now. So which is C. and then we are going to try with the input symbol A. So C means C represents the position 2, 3, 4 and 5. So we are going to work with this. Okay, so we know 2 is having A, and let's go and see 5. 5 is not having A. So we know only 1 and 2 is having A. So here you can see 2 is having A. So 2 position is having A. So here we have only follow position of 2 alone, because 3, 4, 5 don't have A. So what is follow position of 2? Follow position of 2 is 2, 3, 4. So here we have to write 2, 3, 4. So for 2, 3, 4 already we have given a name as B. So again we are going to give the same name. Similarly, go for the D transition of state C with the input symbol B. So we know state C means it is 2, 3, 4, 5. 2 is having input symbol A. So 3, 4 will be having input symbol B. 5 is having input symbol as hash. So we have to consider the union of 3, 4. So if you go and see, 3 is having B, 4 is also having B. So here we have to say follow position of 3 union follow position of 4. So already we have the same thing, follow position of 3 union follow position of 4. So we have to write the same thing here, 2, 3, 4, 5, and for that we have already have the name, we have given the name as C, right? So there is no other new state coming. All for C also we have done with D transition with the input symbol A and B. So we have done with all, right? Now we can draw a transition. So we have done with the D transition. We are going to make a transition table. Okay, we are going to make a transition table from this. So that will ease our job. Okay, we are going to do that. So let's draw a table. So what are the states we have here? We have here A state, B state and C state. So here I am going to write the states A, B and C. What are the input symbols we have for this regular expression A and B? So if you see the regular expression, we have only two input symbols A and B. So we are writing here. Now we are going to see here in state A on input A, where it is going state A. So this is the state A, right? State A on input A, it is going to the state B. So here we have to write it is going to the state B. Similarly, state A on input B, it is going to nowhere, null. So here we have to make it as null. Then state B on input A. So here if you see here, state B on input A, it is going to B itself. Similarly, state B on input B, state B on input B, it is going to C. Then state C on input A, state C on input A, it is going to B. Then state C on input B, it is going to C. So this is how we have to make the transition table. Now it is very easy. We can come to the DFA. By seeing this transition table, we could easily do the DFA. So we know that here the starting state is A. So A is a starting state. Okay. From A on input A symbol, it is going to B. So A state on input A, it is going to state B. Here you can see. Then A on input B, it is not going anywhere. So we will leave it. Then B on input A, this is B on input A, it is going to B itself. So B on input A, it is going to B itself. And then B on input B, it is going to C. So B on input B, it is going to state C. Then C on input A, it is going to B. C on input A, it is going to the state, C on input A, it is going to the state B. So C on input A, it is going to the state B. Then C on input B, it is going to the state C. So C on input B, it is going to the state C itself. Right? So we have done with the DFA. Then we have to find the final state, right? This is the starting state. And who is the final state? So if you want to see the final state, we have a rule already. It says the accepting state are those containing the position of the end marker. So what is the position of the end marker? The end marker's position is 5. So we have to go and see which one have 5 in it. So here you can see this one have the 5. This state, that's the C state alone have the position of the end marker. So C state will, so if you see in all others states, A doesn't have 5, B doesn't have 5. C alone have the 5. What is 5? 5 is the position of the end marker. So here you can see hash is the end marker. What is its position? 5. So C will be the final state, because C state only having the position of the end marker. So we know for the final state we will be drawing the double circle. So this is the final state and this is the starting state. So now we have obtained the DFA. So for this regular expression, we have converted this regular expression to this DFA. Hope you have understood it. Thank you. God bless you all.